In this video, I'm going to walk through some of the automation capabilities that have been developed by Custodela leveraging WebInspect, Fortify, Jira, and Jenkins. We initially started off with the concept of application security in a box, where we have one ESXi server running all of the various components required for an application security program, of course leveraging WebInspect and Fortify. Issue tracking published within Jira, and of course all CI driven by Jenkins. The CI components and the issue tracking components can actually be swapped out for various other tools and technology like Circle CI, Travis, and for issue tracking, whether Git issue or Bugzilla. We've developed against many other components. We actually tie all of these components together with a single sign-on technology known as WSO2. It is open source, and we have a portal that ties all the access to Fortify and Jenkins and Confluence and Jira. Confluence is leveraged for wiki, methodology, process, technical guidance for issue remediation, and so forth. The focus of this video is actually going to be on the automation with WebInspect. Here I have a high-level workflow or technology flow of the automation with WebInspect. Once the static code analysis has been successful and the application is bundled, it is deployed, which at that time you can trigger and execute your Selenium tests, which in this example we will use Phantom.js, where we pull the test scripts, we launch a proxy for WebInspect or Zap. We also have this working for Zap attack proxy. We funnel all of the traffic for Selenium through the WebInspect proxy. We capture a web macro, and then we launch the attack. At the end of this scan from WebInspect, we will pull the results, persist them to an issue repository for us to then complete automation against, with which we publish Jira tickets or Git issue tickets or whatever issue tracker you may be using. We reference Confluence for remediation, and of course the developers will be the ones getting this continuous feedback. So here I'm showing a cloud model of what we have deployed, which we essentially leverage the remote data, the managed database service, EC2 for scaling out WebInspect using a built AMI. We have Lambda serverless functions to trigger the automation capabilities that we've developed, and which can be exposed through their API gateway. Using ECS, we've developed Docker containers that can actually deploy all the various components, with the exception of WebInspect due to the way that the licensing can work. And I believe that will be changing in the future, and Docker will be supported. I would like to quickly touch on the actual flow for static analysis, because we do have closed loop automation with static analysis as well, where we open and close tickets as the developer introduces them into the environment. I'm not going to actually go into a lot of detail for that, but I want to start by showing the portal, which I mentioned leverages single sign-on with WSO2. So here we are with our login. Once I'm logged in, I have a landing page which will get me to all the various components for application security, one of which is the issue tracking, which is Jira in this example. Our wiki, which has methodology and guidance. Our continuous integration tool, which is Jenkins. and of course Fortify. So I'm going to walk through an automation job that we've developed for WebInspect using Selenium. So at the top of our job, we just define a few parameters that we'll use throughout. We will then filter the issues in which we want to cut tickets for in Jira, which for this example, we're going to cut tickets against the high and medium findings from WebInspect. This parameter is actually used by a script that we will start, which will launch the proxy for WebInspect and then listen on whatever port we define. This jar file is the custom code that we have to do the integration with Jira and other bug trackers. So we specify our repo we would like to pull our Selenium scripts from. And of course, we have a few configuration details that are required for automation against Jira. And now we get to the WebInspect pieces. Here we have a script that will start the WebInspect proxy and pass the parameters that we defined above, which are the host and port. And just for the sake of completeness, here is the view of this start. This is a shell script that simply launches the proxy and will provide the actual port, the instance ID back so it can be leveraged downstream. This is a little bit more archaic, I would say, in terms of automation. I actually recommend that you use a tool like WebBreaker, which is open source and is actually great for automating against WebInspect, starting, stopping scans, and just launching proxies. So once the proxy has been started, we can now execute our tests through this proxy from our Selenium scripts. Here is an example of one of our Selenium scripts. It's a very simple test. We're just hitting the website for Custodela for this Java example. We actually pass in command line parameters for proxy, in which if you provide these details, we will actually funnel the traffic for Selenium through the proxy. And we have two separate tests, similar in nature, against Custodela's website. And again, passing the proxy details. Also in our test, we launch an example of a Python script, which again, we launched with proxy configuration. And we have two of these as well. We're actually launching this against a well-known website. If you're familiar with WebInspect, this is a sample website that will come prepackaged as a demo website for WebInspect. So we utilize that here. So if we go back to the automation job here, you will see that we run our Python scripts and pass the host and port for the WebInspect proxy that we defined above. And also we run the Maven test providing for the Java example and provide the host and port defined above. This will execute the script, and at the end we will execute another shell script, which I will show here, which is this section. So what we're going to do is grab that instance ID that was defined above, save the scan as a macro, start the scan, and these are all well documented in the Swagger UI for WebInspect. Then we sleep for a defined period of time because the scan will take a bit of time. And then while the scan isn't complete, we'll wait and continually check to see what its status is. At the end, we will download the XML version and the FPR version. We have developed automation against both the XML version and the FPR version. In the event you use the FPR version, you would first persist the data to SSC, and then we have automation that runs and pulls from SSC and uses filter sets and folders. But in this example that I'm showing, we're simply going to use the XML, and then we will parse the XML, and based on the filter that we provided in the Jenkins job, we will actually cut tickets based on that. So once the scan is complete, we will now run that jar that was defined above, which is our automation jar, and it will take the XML file and cut the tickets, and some of the details that will end up in the ticket are defined above at the top as a parameter. So I'm going to go ahead and launch this job. It takes some time, so I'll circle back once it's complete. The Jenkins build and the scan in WebInspect have now completed, and as you can see, the tests have executed leveraging Selenium Phantom JS drivers in both Python and Java. At this stage, you'll see the WebInspect scan script that I had shown before is being used. And once the scan is complete, it will download the XML and then kick off the downstream automation job, which I will now show. This job actually will take the XML and iterate through and cut the tickets based on your filter set as desired. I will now go to our application security dashboard, which has been populated. And I will walk through a sample ticket that has been cut. Obviously, for the purposes of the demo, this isn't a very wide use case of vulnerabilities, but just an example. So we provide the details of the issue as best we can. And then we provide additional details around the request, the payload, the HTTP response. We also provide recommendations and remediation. A lot of detail is provided by WebInspect. We also have some custom information. As you can see, our wiki guidance is provided here, which will help with common vulnerabilities for remediation. Similarly, if this was a static code analysis issue, you would be given the line number. It would give you recommendations on how to fix the code within the recommendations tab. We would give you the URL of the end branch of the repository that was scanned. Essentially as much details as we possibly can so that we can give continuous feedback to the developer all in one spot. Because we're finding that developers like to use one tool. They don't want to log into several tools, and that's what we've tried to do here is tie everything together and make it as painless as possible and deliver the information to the right person. To show complete closed loop automation, I will actually show this run again, this exact same job, except for I will change the filter set so that we'll only cut tickets that are of high severity. This will cause issues that were set to be medium to close automatically. So I will save this and I will build this again. And I will circle back once it's complete. Again, our scan has completed and kicked off the automation job, and we can now see the results of this job. And we will see that some of the issues were successfully closed. So these are the examples that have closed. So if we go back to our application security issue list, we will find that this has closed, for example, and it just happened. So again, closed loop automation, we have developed this for multiple issue tracking tools. We have had this working with several continuous integration technologies, Drone, Circle CI, um, several others, and of course you can see Jenkins here. We have this working with Fortify as it relates to static code. All of these components can tie into SSC, and SSC can be automated against. So that's all I have for you. Thank you very much.